Welcome to Cloud and Data Science. Today, we're going to continue our statistics and probability unit with outliers. Outliers and statistics. Today, we're going to learn what are outliers and how to detect them and the real-world applications for using them. Outliers. Outliers are something that lies outside in data and is mostly irrelevant to the data. For example, you could see that 9.5 is much further away from the main part of the data, so that would be an outlier. And finding outliers is very helpful when you're trying to remove something that is not realistic in data. So removing outliers improves the accuracy of the data and makes the data more relevant. So real-world applications. So it will help improve accuracy of data, like I said earlier. So like in machine learning data sets, finding outliers and removing something that's not useful will help improve the accuracy of a module. Like if you have cancer detection datasets and you wrote a machine learning model to detect cancer, in the dataset there could be some values that are like wrong or like irrelevant that could mess up the accuracy of your module. So by finding the outlier and removing them, it helps improve the accuracy of your module. And finding outliers is also like helpful when you want like statistic knowledge. So like in your school, if you want to know how many people like got a good score on their test or what's the average score people got on their test, you could remove the outliers. So if one person got like a 0% on the test because they were absent, that would mess up the data since it would make the average go down lower. So if you remove that, it helps give you like actual idea of what the real score was. How do we find them? To find outliers, we must first find the median and interquartiles. How to find the median? The median is basically the middle number, and to find them easily, we could just list them in ascending order. After we listed them in ascending order, we just find the middle number, which we could do that by crossing out numbers from each side till you get to the middle. And if there are two numbers, you just have to take the average. For example, in the first list, the median is 6. That's because that's the middle number, and there's 3 numbers on each side of it. In the second list, the median is 4.5, but there are 2 middle numbers. So since there are 2 middle numbers, we take the average, which gives us 4.5. To find the interquartiles. So we use the same process as finding the median, but interquartiles are basically dividing the data into fourths rather than halves. So we take the median, which is quartile 2, and then we find the middle number between quartile 2 and the lowest number. And we do that again between the median and the highest number, which gives us quartile 3. And that basically divides the data into 25%. And then now we're going to learn about the interquartile range. This is also very needed when trying to detect outliers. So as seen here, the interquartile range can be found by subtracting quartile 3 from quartile 1. So in this case, it's 57 minus 30, which equals 27. So that's the interquartile range. So that's basically the numbers between quartile 1 and quartile 3. And now finding outliers. Since we found the interquartile range and the medians and the outliers, we need to find the outliers. So how we do that is we first take the interquartile range and multiply it by 1.5. And then we add it to the highest number or we subtract it from the lowest number. So any numbers below that from what we got when we subtracted from the lowest number is an outlier, or any number above what we got from adding it to the highest number is an outlier. That's because the numbers are so far away from the actual main data, those are considered outliers. So this is basically an overview of the outlier formula, and as we can see, the lower outliers can be calculated by taking quartile 1 and subtracting 1.5 times the IQR. And the higher outliers can be found by taking quartile 3 and adding 1.5 times the IQR. Outliers example. Example would be we have these 5 numbers, 30, 57, 45, 12, and 70. And we need to find the outliers, if there are any, in those numbers. So the first step would be order the numbers ascendingly. And we would do that because we needed to find the interquartiles. So we need to find quartile 1, the median, and quartile 3. And the median is the same thing as quartile 2. And next, we find the IQR, which is the interquartile range. And to find that, it's quartile 3 minus quartile 1. And then we test using the 1.5 times IQR rule. So we list the numbers now ascendingly, so it's 12, 30, 45, 57, 70. And now we have to find the median. And in this case, we could see that 45 is the median since it's the middle number. And we could also see that quartile 1 is 30 since that's the number between 45 and 12. And since there are only 5 numbers in this list of numbers, it's pretty easy to find the quartile 1 median and quartile 3. And the same thing for quartile 3, it's between the median and the maximum number. And next we find the interquartile range, which is 57 minus 30, or quartile 3 minus quartile 1, which gives us 27. Since 27 is the interquartile range, we can multiply that by 1.5. That would give us 40.5. Now we have to add 40.5 to quartile 3, which would give us around 97.5. And any number greater than 97.5 is considered an outlier. And then to find the lower outliers, if there are any, we would do 30 minus 40.5. So that would be around negative 10.5. So any numbers below negative 10.5 would be considered an outlier in this data set. And we could see that there are no numbers that would match the criteria of being an outlier, so there are no outliers in this set of numbers. But if we have number 111, that would be an outlier since that is greater than 97.5. And it's also obvious since it's pretty far number away from the rest of the data. And thank you so much for watching.